Welcome to GCSE Astronomy. This section is all about planet Earth and specifically the shape of planet Earth. The ancient civilizations, the Mesopotamian, the Norse, the ancient Egyptian, they all had their own ideas about what shape the world was, normally connected to their mythology. For example, the Vikings had this image of Yggdrasil, the world tree, that basically the world was a floating island in a tree, connected with some supernatural realms above and beyond. And some of these ideas are still present in modern day religions also. But at what point did we start to actually look at the evidence and decide what the shape of the world was with our own eyes? So we get to Anaximander in 610 to 546 BCE, an early Greek philosopher. Really started to create something new, started to probe the things around him by making observations of it, rather than trying to find supernatural or spiritual explanations for the things in the world. Try to base things on reason and trying to think about how things might be. Now, Anaximander's contributions included understanding that there was actually space underneath the Earth, that rather than Earth being below and space and the sky being above it, he imagined that the sky must go all the way around the Earth, including the parts of the Earth that are beneath our feet. And that was a major breakthrough. There was also some suggestion that the Earth was shaped at least in a circular fashion, almost cylindrical perhaps. But this was a major breakthrough. It took away this idea that there would be like an infinite number of supports holding up the Earth from down beneath. The Earth was free floating in space for the first time. Now, when did it become a sphere? Well, it became a sphere by Aristotle. Now, Aristotle was also an ancient Greek, and Aristotle was one of the first people to try and understand where we fitted into the cosmos. So there was the suggestion of a spherical Earth that came before Aristotle from Pythagoras, the great mathematician. But in this case, it was offered without any evidence or justification, but morely just because of the purity of the sphere. That was what that was based on. Aristotle looked at these ideas and would try to construct arguments for it based on observation. So let's take a look at the three main pieces of evidence that Aristotle based his observations on. Well, the first was to look at the shadow of the moon. You see, I can gauge what shape I am by looking at my shadow on the floor. If we could look at the shadow of the Earth, we could gauge what shape the Earth is. And strange enough, even though the shadow extends invisibly away from the sun in space, occasionally the moon wanders through its path. And so when that occurs, we get to see the shape of the Earth's shadow on the surface of the moon. Now, Aristotle looked at this and thought that a round shadow suggested a spherical Earth. Now, why did it not suggest a disk of the Earth? Now, a disk would produce a round shadow if it was always exactly sort of square on to the moon. But if the Earth was rotating, which we know that it does because it rotates every 24 hours, then by chance, sometimes we would see that disk tipped at 45 degrees, and so the shadow it must cast would be an oval, or sometimes it would be exactly edge on, and so the shadow it would cast would be a line. We never see this. We only ever see a completely round shadow. Therefore, the Earth must be a globe. Also, observations of Aristotle included things like seeing ships sailing over the horizon and the bottom of the ship disappearing over the horizon. The hull was lower than the horizon and the sails above the horizon. And this occurs because it's going around the curvature of the Earth. It was also noted, even in ancient Greek times, that different stars were visible at different latitudes. Again, explained if the Earth was a globe. Now, sometimes we say, and we talk like that these ancient people were rather primitive because they thought the Earth was flat. Well, it's actually right at the beginning of history that we realize that it wasn't. And so actually, these people were a lot more sophisticated than sometimes we give them credit for. After the time of Aristotle, further thinkers brought their minds to bear on the shape of the world. Eratosthenes, a person that lived within the ancient Greek Empire, but actually in North Africa, and specifically around what is now Egyptian city of Alexandria. He made an interesting observation that if you travelled further down into the old Egyptian Empire to Syene, which is down near Aswan in Egypt, at noon on the summer solstice, the sun was directly overhead, and that's probably because it's very close to the tropic. Whereas in Alexandria, on that same day, those vertical objects cast a shadow, and the only way for that to occur is if Alexandria is further around this curved surface than Syene is. And he actually realised, using a stick, that the angle of the shadow at Alexandria was 7.2 degrees, 1/50th of a full circle. And given that the distance between Alexandria and Syene is about 790 kilometres, then if we recognise that the 790 kilometres must be 1/50th of a circle, it means the whole Earth must be about 39,500 kilometres in diameter. Now, given that the actual value is only 40,075 kilometres, this is stunningly accurate, that for the very first time they knew how big the world was. And even though we knew how big it was really clear that there were very large sections that we had not yet visited or explored. And one of the more difficult questions was, well, how can we when we were entirely dependent on the way that the wind was blowing? In Europe, where civilization was flourishing, it was a easterly wind blowing across the Atlantic Ocean, so you just couldn't head west. But Christopher Columbus found by sailing sufficiently far south along the coast of Africa, you could actually catch a wind going the other way, and in so doing discovered the New World and basically discovered what we now call the West Indies, Bahamas, and etc. Now, shortly afterwards, that was 1492, in 1519, Ferdinand Magellan set off with a fleet of 3 ships, sailed down the coast of Latin America, crossed into the southern hemisphere for the first time, and then across the great Pacific Ocean. He was, in fact, killed by poison arrows as soon as he found the East Indies, but one of his ships managed to limp all the way back and report that the Earth could be circumnavigated. So it was a sphere, and everybody was happy. Until Isaac Newton, because in 1687, in his landmark book, The Principia, Newton suggested that the Earth may not be a perfect sphere, and he realised that it may not, basically by thinking about how objects behave when they're spun really fast. He believed that the Earth might be spun so that it was wider at the equator than it was at the poles, sort of squished at the poles, if you like. And so he actually used astronomical observations to suggest that this was true. Now, the observations he had were kind of rough. They were not taken for the purpose of this work, so they were a little bit sketchy at best. But basically what he realised was that when he measured the latitude between York and London and compared it to what that actual distance was across the ground, and then when he measured the latitude as measured from the sky between the French cities of Roussillon and Dunkirk, and compared it to the distance across France, he realised that the Earth appeared to be about 27 kilometres taller at the equator than it was at the poles. It meant the Earth appeared to be an oblate spheroid shape, a squashed sphere, and he concluded the results were due to the rotation of the planet, and correctly compared it to the oblate spheroid shape of the planet Jupiter that we can see with telescopes. Now, this was a stunning discovery. So 27 kilometres, based on 2 really rough observations, someone had to go and measure it properly. Now, to do so required the longest baseline that they could in 2 very separate places on the Earth. And so in 1735, Pierre Bouguer and Charles-Marie de la Condamine in Peru, all the way in South America, and Anders Celsius of the Celsius scale fame, and Pierre de Maupertuis in Lapland measured the Earth's shape more accurately. And they found that the radius at the equator was 21 kilometres taller than it was at the poles, which is within 2% of the true value that we've now taken careful measurements about. So it's absolutely astounding that sometimes with very primitive measurements we can make such profound and accurate measurements of things like the shape of the Earth. So if the Earth is not a perfect sphere, it actually says something a little bit about what we might find on the surface. What we find is it affects which mountain we call the tallest mountain on the planet. Now, it all depends on how we measure it. Mauna Kea in Hawaii is undoubtedly the tallest mountain from the base of the mountain to the peak of the mountain. Its base is actually deep beneath the sea, and so it is absolutely ginormous. But on land, Mount Everest is said to be the tallest mountain, measured from sea level up to its peak, 8,848 meters. But of course, Mount Everest doesn't actually lie on the equator. A mountain nearer the equator of sufficient height could actually have a peak further away from the Earth's center than Everest. Not necessarily further away from sea level, but definitely further away from the middle of the Earth. And the winner is Mount Chimborazo in Ecuador. It is the mountain whose peak is the furthest into space from the center of the Earth. Further validation of the shape of the Earth came in the Second World War, just afterwards, when rockets became powerful enough to launch out of our atmosphere and to get high enough to see the curve of the Earth for themselves. 1946, using a captured German V-2 missile launched from White Sands in New Mexico, we got our first images down onto the planet from above. Now, getting further away from Earth through the programs by NASA to go to the moon, we get this fantastic Earthrise image taken in 1968 by Apollo 8, the famous Earthrise photograph, showing the spherical nature of our planet as viewed from the moon.